Okay, guys, so the bottom line of this lesson is it's designed to teach you how to take STK's somewhat user-unfriendly interface and turn it into something that will allow you to visit multiple objects through the use of scripting tools that I will teach you how to use and write your own JavaScript for. It sounds potentially difficult, but I'm going to demonstrate that it is not nearly as difficult as it sounds, and any single one of you can learn how to do this in a way that makes your interface and experience within this environment much more friendly.
When it comes to software designed to simulate objects moving in space, I think there's always going to be this battle between high precision versus a agreeable user interface. Something that is designed around an agreeable user interface or even a fun user interface would be more along the lines of like a Kerbal Space Program. That's a straight up video game designed to teach you principles of orbital mechanics and let you have a lot of fun doing it. So the user experience is very important to them as they have built out that software. But in terms of the precision, it's not representing necessarily exact Earth physics. It's more representing physics that will make the principles a little more fun, and the user experience is really the key focus. As far as I know, KSP does not purport itself as a simulation of Earth physics. Now, somewhere in the middle, you might have a software like FreeFlyer that is very good precision and a really respectable user interface. So where does Systems Toolkit by AGI fall in? I think it's in the extremely high precision, at least in terms of the licenses that you can have with this software. But with that high precision as the primary focus, the user interface can be somewhat clunky. STK is a great environment because whether you're trying to represent the flux of energy through satellites, the performance of thrusters in a reasonable or high precision gravitational propagator, it can do all of that. But there are some subtleties to how that software works, and if you're not trained in them, it can be very difficult to do exactly what you want. So this lesson is designed around the idea of teaching you ways that with a little bit of programming know-how, you can retailor the STK user interface into something that is ideally easier for you personally to work in. Because this software can do a little bit of everything, you find the niche that you're attempting to represent with your experience. And then you design a tool that makes that particular niche within this software high functioning and easy to utilize. So I'm going to teach you guys some basic scripting that I think anyone could reasonably understand and learn how to use. And for all of its quirks, STK actually makes this process relatively simple. Here's the design environment that we're going to be building this lesson around. So I have an RPO sat that's just happily drifting through space, and it wants to visit 5 different points along the geosynchronous belt. First, it's going to jump over to point A, then it's going to jump to point B, then to point C, then out to point D, then to point E, and let's just say back to point A. So that's a design environment, and there's a lot of tools already inherent in STK that can allow me to solve for the burns that will make this executable. So let's just jump into RPO-SAT's propagator, and let's visit all of these points. So if you're somewhat familiar with how to break this problem set down, you know that primarily you can utilize something like a target sequence to solve for the maneuver that will take you to point A at the end of a propagation. So this will be a target sequence that solves for a RIC maneuver that allows me to arrive at point A. Arrive at point A, I'm just going to find the relative motion, the relative cross-track, in-track, and radial of this reference selection, which I'll just set to basic reference of A. Select, and now I'm good to go. Let's just say we're going to arrive at point A in 1 hour. We'll turn on these variables for the solutions to work, and then we'll open up the differential corrector that we currently have set up. We'll use our XYZ RIC RIC burn to get to cross-track, in-track, and radial of point A at the end of this propagate, which we have set up to be an hour. So let's go ahead and activate this and run it. Okay, great. And there you can see it, 1 hour flight time to A. Now our next stop is going to be B. That's easy enough. We just copy paste this target sequence that we already have set up the way we want. And now we're going to set up our propagate for arrival at B. Unfortunately, though, if we were to just run this as is, it will just solve 2 target sequences, which take us back to point A. That's because the results of this tab is going to be basic reference, and basic reference is going to be this point here. And if we were to change this to B, in contrast, so now our basic reference is changed. It now changes the basic reference of this object because it is also set up to basic reference. So every single target sequence that is using some relative point defined by basic reference will always, for every single target sequence, use this reference. So if we were to rerun this, we don't get a trajectory that goes through point A and then point B. We just now are only going to point B twice, essentially. Okay, but there's a solution for that AGI has provided, so let's go into the results. And instead of using basic reference, you can use a specified reference. And we'll just change it from A to B. And now let's look at the in-track. Okay, we have to change the in-track too, otherwise now we'll solve for a cross-track of 0 for satellite B, but an in-track for whatever is set up to our basic reference. Okay, so now we have to click that one. Set that one to B. Now we have to click this one and set this one to B. Click OK. I think I changed my reference, so I have to set that back to A. Okay, so now we have a target sequence that is set up for the basic reference of A and the specified reference of B. We should get what we were looking at, 1 hour travel time to A and then 1 hour travel time to B. So let's just run that and demonstrate that that is what we get. And sure enough, here it is. RPO sat visits A, and then 1 hour later, RPO sat visits B. Okay, now we need to come all the way back to C. So we can copy this target sequence, which is better than copying the other target sequence. We'll go into arrival at B, and we'll change all of these satellite Bs to satellite Cs, and then we'll do that for D, and then we'll do that for E, and then we'll have to do another one back to A. Okay, great. That sounds like a lot of work, a lot of clicking, a lot of wasted time in my perspective. The next thing that could potentially waste time is, what if we want to have a delay after we arrive at A before we start our burn to arrive at B? Okay, so now we got to add a propagate here. There will be that delay time. And then what if I want to arrive at B at 2 hours instead of 1 hour? So 1 hour to here, then I wait an hour, then 2 hours to here, then I wait half an hour, then 3 hours to arrive at C. Well, STK can easily do all of those things. We'll just put a propagate here. We'll change this propagate. We'll put a propagate here. We'll change this propagate. We'll change the target. If we ever want to skip the burn at B, then now we have to change the next one to C and so forth. Personally, I find all of those button clickings and STK-isms of adding propagates to be tilting the usability of STK software for the niche that I'm attempting to operate in towards that not super user-friendly standpoint. It's every single one of these would be multiple clicks. So click here, set the specified reference, click here, set the specified reference to A, do that for in-track, do that for radial, do that for in-track rate, do that for radial rate, do that for cross-track rate, do that for semi-major axis, relative semi-major axis, etc. Okay. So this is the problem set that we're designing, that it's not super user-friendly to have to visit multiple RPO targets in a single RPO mission when just using Astrogator as it was designed to be operated. But the nice thing is, all these button clickings and changing values over and over and over is things that are conceptually the types of things that are really good for computers to handle. Computers are really good at, okay, go to propagate and change 3 things whenever I want you to go to a new target. Got it. Computers can do that billions of times faster than I could click through this software. And what I'm going to show you is the code to do that is actually incredibly simple. So in this lesson, we're going to make our first RPO scripting tool, and we're going to save ourselves a heck of a lot of time. And then once we have that tool, we will have it forever. And for any style RPO mission, whether it's this exact scenario or any scenario that we could start from scratch and envision in the future, we now have a tool that we can use every single time as long as we continue to utilize this software. Okay, so what we're going to be using is a tool known as scripting that is native to STK and is a design environment that allows us to do some very basic coding without needing to download Python, MATLAB, Visual Basic, get out a notepad, write a bunch of Boolean scripts, and then try to figure out a way to ingest those into STK. STK already has a relatively decent script running environment for multiple common programming languages. First thing I'm going to do is I'm going to ingest a new object that by default has sort of scripting built into it. And it's going to be called a sequence. So we'll just have this sequence, and you can see it says scripting, and there's a scripting tool. We're going to go into that. But before we start that, the next thing that I always do when I start to build out a new script is first design through the painstaking button clicking the tool that I want to replicate. So in this instance, we're building a tool that allows us to solve for these target sequences around a particular object at any desired value. Then I think through what are the types of things that I am doing over and over and over that I would like to automate. And one is I'm setting up a propagate for how long to wait before I burn. So we'll just call this propagate delay. The next is I'm setting up a maneuver that I have to set to a thrust vector RIC and enable all of these things. So I'll just do that. And then I'm going to have my arrival propagate, and it has to have results that are based on a target. So I'll set all of that up. So I set up the first one the exact way that I want to execute it. And now what I'm going to do is I'm going to nest all of that under one of those sequences. Okay, so now I've got a sequence with a typical waypoint underneath it, which has a delay, a target sequence, a maneuver, and arrival propagations. Every single waypoint that I might build will probably have all of these objects. Now I'm going to go back to the sequence, and I'm going to rename it to be waypoint script, or something like that. Okay, so now I have a waypoint script that I will eventually save so that I can ingest into any STK scenario that will always have these four things in it: a delay, a target sequence, a maneuver, and an arrival. Okay, so let's look at this thing called a scripting tool. Now within scripting tool, there are object properties, calculation objects, and parameters. And then there is some space to write any sort of scripting that you want to put in here. For instance, you can do Visual Basics, MATLAB, or JavaScript by default. And even if you don't have JavaScript or Visual Basic script on your computer, STK can run those natively. For some versions of STK, if you want to code in MATLAB in STK, you have to have downloaded MATLAB. So as you can see, if you set this to MATLAB, MATLAB has not been configured to work with STK, it will give you a warning. I don't know if every STK behaves this way, but at least the one that I'm using, which is 11.7, does. Okay, so maybe this looks intimidating because it has nothing that would tell you what you're looking for right now, but we're going to break it apart. So parameters, the way you think about this is the interface that you want to offer to your users. This is where you're going to take this software that is high precision and turn it into high user functionality. So whatever you set here in parameters, just think, this is what I want to offer my users an opportunity to manipulate. So let's just do the first one that we'll say is going to be RPO target. So I want to give my users the opportunity to set up an RPO target that will change all of those in-track specified references and all those things so they can bounce around all over the place to their heart's content with as simple of an input process as possible. So let's just add a new parameter by clicking this object here. And we're going to name this RPO target. Okay, so there's still some additional information that is in this parameter that we need to fill in. But let's just see what would happen if we just clicked OK right now. Now when we go back to the original screen of the Waypoint script, we can see I have this RPO target, which has something that any user can type whatever they want into, and it will do something. Right now it's not doing anything because it's just a user value. Let's go back to the scripting tool. Okay, so there's some types of things that users can do to this box here, which is labeled value. And it could be Boolean, date, double, enumeration, integer, quantity, or string. So if you set this to a date, then a user will have to type in some date here. And if I were to click OK, you would see that a user could set this date to any date within their current design environment, and that would be great. We'll probably come back to this later. If you were to set it to an integer, they would have to provide you some sort of a number. If they were to set it to string, they would have to provide you some sort of word. Enumeration gives them drop-down menus that they can select from. The first one that I want to use here is going to be a string. Now, if you are somewhat familiar with strings from other programming design environments, you know that a string is just words. It's not a number, it's not a date. The only property it has is letters or some sort of noun, verb, something like that. The reason I'm setting this to string is because RPO target will be a word. For instance, the value would be A. Next, what I'm going to do is I'm going to go to user comments, and I'm going to say, this is what this parameter is designed for you to do. I am talking to the users in this parameter section, and I'm just going to tell them, type here the name of the RPO target you wish to waypoint to. And then I'm going to click OK. So now I have this parameter known as RPO target. It currently has no value. Eventually we'll type the value A in here. And then I have a user comment that tells the user what they're supposed to do in this parameter. Now my next task is to tie this RPO target parameter to these three components here, and really this reference component here. So I have to find a way that whenever the user types in the letter A, it will automatically set this reference to the satellite A. If they type in the letter B, it will set the reference to the satellite B, and so forth. Okay, so where are we going to find that? Well, STK makes this very easy, and they have this box here called Object Properties. These are all the things that are in the current MCS for Astrogator that you could go out and manipulate. So let's just go ahead and add a new one. And we'll give this a name of in-track target. And then we're going to open up the properties of in-track target. So in-track target is currently on the propagate that is arrival at whatever object I want. So what I need to do is go find that object. So let's just find it. And I know that it's in the arrival propagate. So here's the first propagate called delay. And then you see everything else has target sequence in front of it because it belongs to target sequence. And then the name. So there's this propagate for arrival and a propagate for a object for maneuver. So I'm looking for the target for my in-track value, which is going to be an arrival. So let's click that. Okay, so now I can select from anything that's currently in that propagate. So let's just go and find the attribute that we're looking for. And it's going to be one of these things. These are all the things that are inside of that propagate. And you can see the max prop time, the segment color, all of those things are in here. But the reference to the in-track target is going to be one of these things that is under results. Now, if I didn't have anything in results of this propagate, none of these would be showing up. Because I've already set up the propagate, I have access to all of these values. So I'm trying to find the in-track, and it's going to be the reference. So what is the object that I want to target here? So results in-track reference. I'm just going to click OK there. And I'm going to click OK, and I'm click OK. Just to let you know how I found this. So I was in results of target sequence.arrival. And the name of the object that I was looking for was called reference. That's this box here. I have now created a object that points exactly to this box. All right, so let's jump back into the script. Now all I need to do is write some very basic JavaScript language. And when I say basic, I mean super basic. Let's just write the name of this object equals the name of this object. So let's try that out. Intrack target. And I believe capitalization matters here. I can't remember how JavaScript exactly works, but I believe it matters. Equals RPO target. Great. The problem is we have to set all three of those. So let's just copy this one and paste it. We'll rename it to be radial target and cross-track target. Because all of these are pointing to that arrival propagation, I can actually just double click on these and change them to what I need. So this next one is called radial target. So let's just go find that. It's going to be results radial reference. And then the other one is called cross-track target. So let's go find that. Cross-track.reference. Great. And then we'll click OK after we have written the script. So I think JavaScript denotes things with a semicolon. I don't know how necessary it is. Let's just try it without and see if it gives us an error. So we got intrack target, and we have radial target equals RPO target, and cross-track target equals RPO underscore target, which is the name of this string over here. And then let's go ahead and click OK. Okay, so now I have whatever is typed in here will be what ends up in this object here. So let's just first set it A, and let's see if this tool works as designed. Okay, so looks like we successfully RPO'd to A. Let's just see if we can now change it quickly to B. Okay. So now we have set it to B. Let's just see if we can change it to C. And indeed, it does that 1 hour delay and then goes to C. So our tool is working. Fundamentally, the tool is working exactly as we designed it. And we only did a few steps, and now we can very quickly change our target. So if I wanted to do the original plan of just burn around to those 5 targets, let's just do that right now. So I'll just copy this. And you can even shrink this down because you don't care what else is in there. It makes your MCS a little neater. Just copy it, and then we'll paste it. This first one we'll set to A. Second one we'll set to B. Next one we'll set to C, which was already written in there. Great. This one will be D. And this one will be E. So now we have a waypoint that will go to RPO target A, B, C, D, E, and we'll just run it. There's A. Okay, it took a lot of guessing from STK because forgot to set a reset requirement underneath these to start from scratch. But it looks like all 5 of them were successful. And here we see we get to A, we wait an hour, we go to B, we wait an hour, go to C, we wait an hour, we go to D after waiting an hour, and then we fly back to E. Now let's say that we just wanted to change the order. Okay, let's go to C first, then E. Relatively easy for us to change that. Let's go C, then E, then we'll go back to C, then we'll go to D, then we'll go back to E. So now we're going to C, then E, then back to C, then to D, and then back to E. So very quickly, we're able to change our targets on the fly without any button pressing. All we have to do is go in here and change the name of the target. So we could stop here and we have already made our lives way easier. But I don't think that that's really sufficient, because why don't we also add in the ability to change the amount of time we wait and the amount of time it takes for us to arrive. That is something that I am constantly trying to dial in. So yeah, let's just add an opportunity for us to do that. So let's just delete these other waypoint scripts that we made because they won't be our final product. And let's just jump back into our original script and let's go back into scripting tool. So now I want to give my user, so I go over to parameters, the opportunity to define what my delay time will be. So I'll just go here, add new, and I'll say this is going to be my delay time set. And I want to make that a type here, the delay in hours you want to wait before beginning a burn. So here's my tip to the user of how to use this. And let's just say I want to do this at 2.2 hours. Okay, so STK was willing to accept that value, which means a double is an appropriate type. So now I just have to go and find a way to tie whatever is typed into here to that delay parameter. So let's just add a new object. We'll call this delay time, which is very similar to this. And now we just have to go find the object that it lives in. So let's go into properties. We know that it lives in the delay propagate, so there it is. And the value that we're looking for here is going to be the trip value. So let's just go ahead and click that. We'll click OK, click OK, click OK. How did I know that that was what I was looking for? If you go in here, you can see trip is inside of this delay propagator. Sometimes there's some nuance to how these are written. You're going to just have to figure it out through a bit of trial and error. But in general, they will almost exactly match whatever is written next to the box that you're trying to manipulate. Now, if you notice, the unit, the default unit for this right now is seconds. I'm going to change this to hours. That way, whenever I type in something here in my double, it is only going to be represented in that box as an hour instead of a second. Okay, now the final step that we need to do is join our parameter to our object property. So we're going to just say delay time equals delay time set. So just like before, we just take the object property and we set it equal to the name in the parameter. So now the user has the opportunity to change delay by whatever they type in here. So let's just go ahead and run this and see if it works. Okay, we see convergence. And let's just figure out, did we get the delay that we were looking for? So we should see 2 hours and 0.2 seconds go by. So let's just set this around. Here's our first half hour, second half hour, third half hour, fourth half hour. So now we're at 2 hours, and then somewhere we should have begun our maneuver, which you can see that happens at exactly 2.2. Let's just set our delay to half an hour or 0.5. Now what you'll see is we only wait a half hour and then we begin our burn. So we can very quickly change that over and over as fast as we want. Oh, we almost have a pretty decent tool here. Let's just find a way to change this arrival time, and we will have 3 very simple, very rote processes that we have now solved with a scripting tool. Okay, so the technique I'm going to use to do that, and go back into scripting. Here's something new for the users. So I'm going to build a new parameter, and we'll just say arrival time set. We already know a double is appropriate for the other time, so let's just leave this as a double for this time. It's going to be almost exactly to this delay time one, so we could just copy paste it, but let's just make a new one for the sake of showing all of the complete steps. We'll call this arrival time. We'll go into the properties of arrival time. We'll find the object. It's not going to be this delay. It's going to be the arrival propagate, which is similar to where the target lives. We're going to find the attribute that we're looking for. It's just like what we did with the delay time. It's going to be the stopping conditions trip value of that propagate, so duration trip value. Click OK. The unit is not going to be seconds, because if we let the user type in seconds here, it will not be what we have designed for the user experience. So we need to change this to hours. So now whenever a user types in a value here, it will be turned into hours in that input box. Now we write our very, very basic JavaScript arrival time equals arrival time set, and we are good to go. So now let's just set our arrival time at 0.5. So we're going to have a delay of half an hour and then arrival of half an hour. We forgot to tell the users what we wanted here, so let's just go back, make the user experience better for them. Type here the arrival time in hours you want to get there. Smiley face. Great. So now we have an even happy experience for our users. Let's just go ahead and run it, see if it works. It was able to converge, so let's just go back to our 3D graphics and validate that we got what we were looking for. So we should wait a half hour and then arrive in a half hour, which is indeed what this does. Now we've got an even better version of our original script. Let's do 3 arrivals. So the first one, let's go to point A. Let's not wait at all. Let's just do our burn right away. Next one, let's go to point C. We'll wait 15 minutes or 0.25 an hour, and then we'll arrive in 1 hour. And then finally, let's visit point B. We won't wait at all, so as soon as we get to point C, we'll burn for point B, and let's get to point B in 4 hours. Okay, everything looks good. So we have a waypoint to A that will happen immediately, and then get there in a half hour. We'll wait 15 minutes, and then we'll get to the other object, C, in an hour. And then we will, from immediately at point C, because we have no delay, get to point B in 4 hours. Let's run it and see if it works. Looks like it was all successful. Let's see if it gave us what we were looking for. Okay, so we should be going to point A in 1 hour, or excuse me, a half hour is what we designed. So yeah, we have to point A in a half hour. Our time step is currently set to a half hour, so there it goes. After we get to point A, we're going to wait 15 minutes. So let's just knock our time step down to 15 minutes or 10 minutes. So you can see it takes us about 15 minutes to get there. And then we'll go to point C. Immediately as we hit point C, we're going to get to point B in 4 hours. Okay, so we just have now designed a tool that is even better. And we can, on the fly, change our target, delay, and arrival time without having to go through all the button clicks. And we can even set that to 0, and it doesn't break the tool. So we can essentially erase this delay by setting it to 0 without ever actually having to delete the delay itself. If you ever want to see if your tool works without having to actually run the MCS, you can also click Apply Changes here. And what you'll see is this delay is now set to 0 seconds. If your tool is broken, it won't work. Let's set this to 7, Apply Changes, and now our delay is 7 hours long. And we can even change the target if we want. So we can change the target to D here, click Apply Changes. You'll go into the arrival, and you'll see that now it's referencing satellite D. And set it to E, set it to 2, set it to 22. Click Apply Changes. We have a delay of 2 hours, arrival 22 hours later, and that arrival will be at satellite E. Great, our tool works. So let's just say Waypoint script beta. Let's delete these others. And how can we make this available to all of our STK experiences from now on? We just take this, you right click on it, and then you say Add to Component Browser. Now, whenever you input a new object, Waypoint script beta will always be one that you can choose from. So anytime I click on this, it will be designed with this script and it will have these objects inside. And now I can just flood my MCS with as many Waypoint script betas as I want. And I can bounce from object to object to object to object. I'll show you guys another lesson. If you actually look at the Waypoint script that I built, it has probably about 17 other things in here that a user can on the fly change. Like, what if I want to disable cross-track burns from my waypoint? Or what if I want to change this delay into a plane cross or an epic time? All of those are in the scripting tool that I made. The programming language gets a little more complex. The more things that you add in here, you have to sort of know how to do good if-then statements. But I think even if you just wanted to set up a tool like this will dramatically decrease the amount of time you have to spend clicking through and changing target objects and changing arrival times and changing delay times and things like that. So as a basic introduction to this concept, I hope that you find this useful in your utilization of this software.
Hey guys, just as a bonus, I figured I would show you the tool that I use. As you can see, there's a few more things in here. So I give my users the opportunity to set an epic time or a duration so that they can define a specific time to arrive versus a delay time. This is an enumeration, so this is what that drop-down menu could look like. I also go into the target sequence and allow them to move in any distance from the target that they're trying to RPO around. I turn cross-track burns on and off. Here's what the language for that looks like. So here's all those different user inputs. So I have enumerations that allow them to select between two values. Let's just look at the parameters and properties that I set up for that. So you either have a 0 or a 1 here. In terms of targeting an R, I, or C point around a particular target, all of that you can find inside of the object result that is inside of the target sequence itself. So you find that here in the target sequence. And inside of the target sequence, there's a whole host of opportunities to select some values. Here's some of the language that supports this script. So you can kind of pause and get some ideas if this is something that you want to build into your tool. Mine also has the opportunity to limit the amount of delta V to burn and turn cross-tracks on and off. A little bit more advanced, but you could certainly learn and replicate this in an afternoon.